In today's video, we dive into a phenomenon so powerful it has the potential to disrupt our modern way of life: solar flares. From the historic Carrington event of 1859 to the looming threat of geomagnetic storms, we explore the risks solar flares pose to our technology-dependent society. With the possibility of global internet shutdowns and even a regression to the Stone Age, understanding these cosmic events has never been more critical. Join us as we unravel the complexities of solar flares, their frequency, and the steps we can take to prepare for their potentially catastrophic impacts. 1. What is a solar flare? A solar flare is a sudden burst of energy on the sun's surface caused by the release of magnetic energy. These flares emit intense radiation, including X-rays and ultraviolet light, and are often accompanied by coronal mass ejections, CMEs, which release charged particles into space. Think of it as the sun having a tantrum, flinging energy and particles out into the solar system. These flares can vary in strength, with some going unnoticed and others having the potential to disrupt our daily lives. Solar flares are a natural part of the sun's activity, but their impact on Earth can be anything but ordinary. 2. The Carrington event of 1859. The Carrington event of 1859 stands as a historical reminder of the potential havoc solar flares can wreak. Named after the British astronomer Richard Carrington, who first observed it, this was the most powerful solar storm on record. It caused massive disruptions to the telegraph system worldwide, with operators experiencing electric shocks and telegraph paper catching fire. The aurora borealis, typically visible in polar regions, was seen as far south as the Caribbean, lighting up the night sky in vibrant colors. If a similar event were to occur today, the consequences would be catastrophic given our reliance on technology. 3. Potential impacts on modern technology. A powerful solar flare could have devastating effects on modern technology. Imagine waking up to find your smartphone, GPS, and internet not working. A significant solar flare could knock out satellites, disrupt GPS systems, and damage power grids. Our modern infrastructure relies heavily on electronics, making us far more vulnerable than during the 19th century. In a world where a simple GPS malfunction can delay flights or confuse navigation systems, a solar flare could bring entire industries to a standstill. The ripple effect of such a disruption would be felt globally, affecting everything from communication to transportation. 4. Geomagnetic storms. Geomagnetic storms are a direct consequence of solar flares and CMEs. When charged particles from a CME interact with Earth's magnetic field, they generate these storms. The interaction induces powerful electrical currents in power lines, transformers, and pipelines, leading to potential widespread blackouts. Picture a row of dominoes. Once one falls, the rest quickly follow. Similarly, a geomagnetic storm can trigger a cascade of failures in our power infrastructure. The result could be prolonged power outages, affecting homes, businesses, and essential services. The challenge lies in predicting and preparing for these storms to minimize their impact. 5. Global internet shutdown. In our interconnected world, the internet is the backbone of communication and commerce. However, solar storms could destroy undersea communication cables and satellite links, leading to a global internet blackout. Such an event could last weeks or even months, as repairing the infrastructure would be a massive undertaking. Imagine the chaos of not being able to send an email, stream a movie, or conduct online banking. Businesses would grind to a halt, and personal communication would revert to pre-digital methods. The economic and social impact of a prolonged internet outage would be profound and far-reaching. 6. Knocking us back to the Stone Age. In the event of a severe solar storm, the world as we know it could change dramatically. Power outages could last for months or even years in some regions, effectively knocking us back to the Stone Age. Essential services like food supply chains, water systems, healthcare, and banking would collapse without electricity. Imagine cities without power, where food spoils, water pumps fail, and hospitals struggle to operate. The absence of electricity would not only affect daily conveniences but also pose significant challenges to survival and societal order. Such a scenario underscores the need for preparedness and resilience. 7. Risk to astronauts and spacecraft. The effects of solar flares extend beyond Earth, posing significant risks to astronauts and spacecraft. Astronauts aboard the International Space Station and satellites in orbit are especially vulnerable to high doses of radiation during a solar flare. This radiation can damage electronics or pose serious health risks to astronauts, potentially jeopardizing missions and lives. Space agencies take these threats seriously, implementing protective measures and monitoring solar activity closely. However, the unpredictable nature of solar flares means that space exploration always carries an element of risk. 8. How often do solar flares occur? Solar flares are not rare occurrences. They happen frequently during the Sun's 11-year solar cycle. Larger flares are more likely during periods of peak activity, when the Sun is particularly active. We are currently in solar cycle 25, which spans from 2020 to 2031, and activity is ramping up. This increases the likelihood of strong solar flares that could impact Earth. While most flares are harmless, the potential for a significant event remains a concern. Understanding the solar cycle helps scientists predict and prepare for periods of increased solar activity. 9. Warning time is limited. One of the challenges in dealing with solar flares is the limited warning time. While we can detect solar flares almost immediately through telescopes and satellites, the accompanying CME takes 15 to 18 hours to reach Earth. This short window leaves little time to prepare, such as shutting down power grids or grounding flights. The race against time emphasizes the importance of having robust emergency plans in place. Early detection and rapid response are critical in minimizing the impact of a solar storm on our infrastructure and daily lives. 10. Mitigation and preparedness. Windham, as the name suggests, is a city where the wind is a defining feature. Located in southwestern Minnesota, it experiences strong winds throughout the year. The city has embraced its windy reputation by investing in wind energy projects, contributing to a sustainable future. Residents have adapted by building homes with windbreaks and using wind-resistant materials. The community also hosts educational programs focused on wind energy, encouraging the next generation to appreciate and harness the power of the wind. Windham's residents have turned their unique climate into an opportunity for growth and innovation,